Hello, everyone. So today we're going on to a very important concept in trigonometry. Okay, and it's the idea of the unit circle. So I'm going to show you what it's all about, the man says. So here I have a circle, which I am now going to divide. Okay. So I've divided that circle in half. So let's use our basic trigonometry, 360 degrees, 180 in each half. Okay, if we further divide it, we get 90 and 90. And further divided down here, we get another 99. Now you don't have to do this. This is kind of done for you in your log tables, but it's kind of not. But it's about, this video is completely about explanation. That's all this is about, explanation. Okay, so there's a couple of kind of things we need to kind of think about when we're talking about angles. So first and foremost, I'm just going to draw over here a smaller little one, just to kind of, sorry, put too much pressure, that's what happens. So just a smaller little one over here, just for a second. Okay, so this is just a smaller version of the same one. I just want to kind of show you a couple of little things that you're going to, you could probably kind of know, but you kind of need to know. Okay, we use the unit circle to find angles and to find relationship between angles. That's the most important thing we use it for. Okay, and it comes up quite a bit in a couple of different areas of trigonometry and stuff that uses trigonometry. So first things first, and this is probably the most important bit. Okay, there are 4 quadrants. Okay, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the first, second, third, and fourth. Okay, each quadrant contains 90 degrees. Okay, this is 0 to 90. Okay, this one is 90 to 180. This is 180 to 270, and this is 270 to 360, which is also occupies the same space as 0. Okay, so it's a full rotation of 360 in here. Okay, that's the basics of it. Now, when we're dealing with a unit circle, the important thing to realize is that the radius of the circle, the radius equals 1 unit. Now, it doesn't matter whether that's 1 centimeter, 1 meter, it's just 1 unit. It's not 1.2 of a unit, 1.3 of a unit, it's 1 unit of whatever. So everything else, if it's referenced to 1 unit. Okay, just keep that in mind because that'll be important in a few minutes. But back to this anyway, I just want to show you. Okay, when we're reading from a unit circle, we read from the positive x-axis point, this point here, this line here. And if it's a positive angle, we read it anti-clockwise. We go this way. Okay? If it's a negative angle, we go backwards. Now, I'll show you that with 2 small little examples if you'll bear with me. Okay? Why that keeps happening? I think I know why it keeps happening. Because my pencil is longer than my compass. Should never be the case. It should be nearly equal if possible. There, I should do it. I'll draw another one down here. Right, so I'm going to draw 2 scenarios, one with a positive angle, one with a negative angle. Okay, so again, I'm just going to throw in an XY just to give you that kind of reference frame of mind. but these don't have to be accurate. It's just for illustrative purposes. So if I want to do 210 degrees and I want to do minus 100 degrees. So watch. Okay, 210 degrees. So there's a full 90. There's a full 180. And it actually goes as far as 30 degrees in there. So from there right back to there is 210 degrees. Okay, hope that makes sense to you. So if I wanted to find the sine, cos, or tan of 210 degrees without a calculator, there'll be a way of figuring out what coordinates on the unit circle that exhibits, and from that find the sine, cos, and tan of it. But we'll come to that in a while. But first, that's how you find that angle. It's anti-clockwise because it's positive. If I want to go to minus 100, well then there's 90 and there's 100 because there's 10. That's 10 degrees and 90 degrees. There's 100 degrees, but you're going backwards. Okay? So even though I know that's 90, we're considering it minus 90 and minus 10 to give you a minus. So you're going backwards. Okay? So that's a subtle little difference that you have to be aware of. If you find yourself dealing with a negative angle, you can work backwards to it by going clockwise. And if you find yourself at a positive angle, which most of them are, you just go anti-clockwise to find it. Okay? So that's the very, very basics of it. Now, let's have a look at our unit circle. So what I am going to do is, and this sounds a bit crazy, I am going to draw a different color. Use different color because I want this to look nice and pretty for you. I'm going to draw a line. So the first things first, that line is 1 unit long. People wouldn't argue with me on that one, I don't think. Okay? So that is 1 unit long. Now, here is the cool piece of it. And I think this is pretty cool. While that is 1 unit long, if I drop a perpendicular back down to the x-axis, and then I want to find the reference sine, cos of this one, all I need now is to work out, well, I haven't the faintest idea what that is, but I can, and this is the important bit, okay, but I can, and I can't emphasize this enough, I can say for sure that whatever height this is, I can call it y, because it's y up the y-axis, it's y distance up. And similarly, I haven't a clue what this is, but I know it's definitely x along the x-axis. So bear with me now. Let's now figure out what the cos and the sine of theta is. The cos of theta is opposite. Sorry, cos of theta is adjacent over hypotenuse, which is 1 unit, which means that the angle itself, okay, cos of theta times 1 is equal to the coordinate at x. It's that point there. Okay, so park that in your head for a second. X is going to be the cos of theta because it's times 1, so it's just the cos of theta. Now let's do the sine. The sine of theta is opposite over hypotenuse. Cross multiply. Sine of theta times 1 is y. So what's that coordinate there? What is that coordinate there? It's x comma y, isn't it? X comma y. But what do we say x is? x is cos, and y is sine. So you see what you've done without using a calculator. If you want to find sine, cos of any angle under the sun, all you have to do is make the angle, draw a line to a unit circle, and whatever coordinate you have, that's the sine of it. I said the x value is the sine of it, the y value is the x value is the cos of it, the y value is the sine of it. Now, isn't that pretty nifty? Okay, that's what we're going to use it for. Okay, and you can do this the whole way around. You get the sine and the cos of any angle. Okay, now you're asking yourself, what about the tan? Tan isn't that actually hard to find, would you believe? Okay, we'll come on to the tan in a minute, but that's the basics of the unit circle. Okay, so in each of the 4 quadrants, you're going to be able to figure out something. Okay, so what I'm going to do is I'm going to redraw it, for want of a better word, and show you a couple of little addendums to it, for want of a better word. Okay, so very, very quickly, a quick redraw. Very quick redraw here. It's not 100% accurate, but it doesn't need to be. So in the first quadrant, all are positive. So the sine and the cos and the tan of any angle between 0 and 90 inclusive is positive. Okay? It just is. When you go between 90 and 180, if you notice, your y values will be still positive, but your x values become negative. Okay? And because your y values are still positive, that means that the only values that will be positive here will be the sine. Your cos and your tan will be negative. Okay? When you get down here, we have 2 negatives. So you'll have negative for sine, negative for cos, but the tan, because tan is sine over cos, it's rise over run, that's going to be positive. So basically, when you get the tan of any angle between 180 and 270, it'll always be positive, whereas you get the sine or cos of an angle between 180, you can check it on your calculator, they'll be negative. Okay? So, that's just one of those weird little things that can happen. Look, sine of 192 is a minus number. The cos of 192 is a minus number, but the tan of 192 is positive. It's magic, lads. It's literally magic. Okay? And finally, well, what are we missing here? All sine, tan, of course, here. Cos is positive here. Okay? So, in each of the 4 quadrants, there is something different. First quadrant, they're all positive. Sine, cos, and tan. Second quadrant, only sine is positive. Third quadrant, only tan is positive. And fourth, only cos is positive. Okay, so it's a pretty cool and nifty little thing to figure out. Okay, and that does bring us on to tan. What is tan? Okay, well, let's think about it. Let's go back. If I, for example, get color here. Okay, so let's say I drew that line here and I have this angle from there to there. So it's a positive angle. Okay, what is that coordinate? Okay, that coordinate is going to be a negative x and a positive y, but we don't call them x and y in the unit circle. Okay, that means it's going to be a negative cosine and a positive sine. So it's going to be minus the cos of the angle, comma, the sine of the angle. That's why cos is negative, sine is positive. But what about tan? What about tan? Where are we going to derive tan from? Okay, well, Go back to your right angle triangle just for a second, just to visualize it. Okay? Let's pick an angle. Okay? The sine of that angle is this side over this side. Am I right? The cos of that angle is this side over this side. But the tan of the angle is opposite sine over adjacent cos. So tan is actually the sine over the cos. I know it sounds crazy, but it is. It's true. Okay, so it's built by combining the two ratios. Okay, I'll show you a concrete example of that because I don't want to leave this now until we still have a lot of bits and bobs to do, but you know, this is an important part of it. Okay, so I'm going to show you a little example just to show you that I'm not lying here. Okay, let's take we'll take a real one. Okay, right angle, theta, 3, 4, and 5. Okay, so if I'm right, then if I get the sine of the angle and divide it by the cos of the angle, I get the tan of the angle. So let's get the sine of the angle. Well, first of all, let's get the tan by just reading it off. Tan is opposite over hypotenuse, 4 over 3. So the tan of theta is 4 over 3. Let's park that there and show how it's true. Okay, so let's show that this is true. So let's get the sine. So the sine of theta is 4 over 5. And the cos of theta is 3 over 5. So if I'm right, 4 over 5 divided by 3 over 5 should be 4 over 3. And is it? Yes, it is. Watch. What's our rule? Top by bottom, middle together. That's 20 over 15, which is 4 over 3. So that's your reasoning for why sine over cos is tan. And that's why this is so powerful. Because if you know those coordinates or know the ratios, then you can get the tan. The tan is just this divided by this. And that's why, if you look at it carefully, that's positive, that's negative, and then that divided by a negative is also a negative. That's why you only have sine as being the positive one here. Okay, so that's the basic story of our unit circle. We'll come back the next video and do more on it because we're not finished on it. There's a lot more to do, but you need to kind of absorb that along with the next video, and together you will have a lot to go on. Okay.